In this video, I want to talk about how to balance a chemical equation. So let's start with this example. Let's say if we react magnesium with nitrogen gas, it's going to produce a compound called magnesium nitride. So what do we need to do in order to balance the chemical equation? We need to make sure that all of the atoms on the left side is equal to the number of atoms on the right side. So what we're going to do is list out the number of magnesium and nitrogen atoms on the left side as well as on the right side. So on the left side, I only have one magnesium atom. If you don't see a number here, then the coefficient is 1. And also, if you don't see a small number here, the subscript is assumed to be 1. So what you do is you multiply these two numbers. 1 times 1 gives you 1. But intuitively, if you don't see anything, you know that you have one magnesium atom on the left side. Now, how many nitrogen atoms do we have on the left side? Well, we have a coefficient of 1 and a subscript of 2. So 1 times 2 is 2. So there's 2 nitrogen atoms on the left side. On the right side, the coefficient is 1 as well. So 1 times 3 is 3, which means that we have 3 magnesium atoms and only 2 nitrogen atoms. 1 times 2 is 2. So right now, looking at the left side and the right side, we can see that the number of nitrogen atoms are the same. So we don't have to worry about that. However, the number of magnesium atoms, they're different. So what do we need to do to make them equal? What we need to do is multiply this number by 3. And we can do that by putting a coefficient of 3 in front of mg. Now, it's important to understand that when balancing equations, you could change the coefficient, but you cannot change the subscript. Make sure you understand that. So you cannot change this number. Now, once we put a 3 in front of mg, this number changes. So now we have 3 magnesium atoms on both sides of the equation. So at this point, the equation is balanced. Now let's work on another example. Let's react nitrogen gas with hydrogen gas to make ammonia, NH3. So using the same techniques as the last example, go ahead and pause the video. Take a minute to work out this example. So let's make a list of the atoms that we have on the left side and on the right side. So on the left side, we could see that we have 2 nitrogen atoms. We also have 2 hydrogen atoms. On the right side of the equation, the product side, we only have 1 nitrogen atom, but we have 3 hydrogen atoms. So what do we need to do to make the atoms equal on both sides of the equation? Well, for one thing, we can balance the nitrogen atoms by multiplying this number by 2. So let's put a 2 in front of NH3. So now we have 2 nitrogen atoms. 2 times 1 gives you 2. Now, how many hydrogen atoms do we have on the right side? Well, if we multiply 2 by 3, that will give us 6. So we need to change this number. Now, these two, they're not equal. So how do we make them equal? In order to change the 2 into a 6, we need to multiply 2 by 3, because 6 divided by 2 is 3. So let's put a 3 in front of N2. I mean, not in front of N2, but in front of H2 rather. So now we have 6 hydrogen atoms on both sides of the equation. And at the same time, we have 2 nitrogen atoms on both sides. So now the equation is balanced. Now, for those of you who want more practice problems on balancing chemical equations, check out the links in the description section of this video. What I'm going to do is I'm going to post a few links where you could find more practice problems on balancing chemical equations, including harder examples for those of you who are looking for those challenging problems. So take a look at that when you get a chance. Now let's work on the next example. So let's react elemental sulfur, which exists in the form of S8, and we're going to react it with fluorine gas to make sulfur hexafluoride. Go ahead and balance this equation. So there's two elements we need to worry about, sulfur and fluorine. On the left side, we can clearly see that we have 8 sulfur atoms, and we only have 2 fluorine atoms. On the right side, we have 6 fluorine atoms and only 1 sulfur atom. So what do you think we need to do here? Should we balance the sulfur atoms first or the fluorine atoms? Well, if we balance the fluorine atoms first, let's see what's going to happen. So we need to multiply fluorine by 3, because 2 times 3 will give us 6. And you can see that 3 times 2 is 6. Next, we'll have to balance the sulfur atoms. The only way to do that is to multiply this number by 8. So if we put an 8 here, this will change. However, the number of fluorine atoms will change. On the right side, it's going to be 8 times 6, which is 48. Which means that we're going to have to change this number again. So let's go ahead and do that. To get 48, if we take 48 and divide it by 2, that will give us 24. So we need to put a 24 in front of fluorine, because 24 times 2 is 48. So now we have the same number of fluorine atoms, and we have the same number of sulfur atoms. So it really doesn't matter which element you balance first. Sometimes it's beneficial to balance one over the other, but in the course of balancing the equation, you can fix whatever mistake you made until you get the right answer. Now let's try this example. We're going to react propane C3H8 with oxygen gas O2, and it's going to produce carbon dioxide CO2 plus water H2O. So this time we have 3 elements that we need to balance in this chemical reaction. So this type of reaction is known as a combustion reaction. Whenever you have a hydrocarbon, like propane, reacting with oxygen gas, it's always going to produce products such as carbon dioxide and water. Now let's make a list of the number of atoms of each element that we have on both sides of the chemical equation. So on the left side, or on the reactant side, we have 3 carbon atoms, 8 hydrogen atoms, and 2 oxygen atoms. On the right side, we only have 1 carbon atom. Now we have 2 hydrogen atoms, and the number of oxygen atoms we need to perform addition, because we have 2 in carbon dioxide but only 1 in H2O. So 2 plus 1 will give us 3. So now how do we go about balancing a combustion reaction? It turns out that for this type of chemical equation, it's helpful to balance the carbon atoms first and then the hydrogen atoms second, and you want to save the oxygen atoms last, because you can easily adjust this number since you have a pure element, since this substance only contains oxygen. So let's balance the carbon atoms first. What we need to do is, we have 3 on the left, 1 on the right. So we need to multiply 1 by 3 to get 3. So let's put a 3 in front of CO2. And so we're going to have 3 carbon atoms on the right side. Now, this is going to change the number of oxygen atoms on the right side. So now this is 3 times 2, which is 6, plus 1. So now we have a total of 7 oxygen atoms on the right side. Now, what about the hydrogen atoms? So we have 8 on the left side, 2 on the right side. 8 divided by 2 is 4. So this tells us that we need to put a 4 in front of H2O. 4 times 2 is 8. So now the number of hydrogen atoms on both sides of the equation are now the same. So the carbon atoms are equal and the hydrogen atoms are now equal. So the last thing we need to do is balance the oxygen atoms. Now, by putting a 4 in front of H2O, we also change the oxygen atoms again. So we need to recalculate it. It's no longer 7. Here we have 3 times 2, which is 6, and 4 times 1, which is 4. And so if we add 6 plus 4, that will give us 10. So we now have 10 oxygen atoms on the right side. Now 10 divided by 2 is 5. So we need to put a 5 in front of O2 because 5 times 2 is 10. Now the number of oxygen atoms are the same. And so at this point, the chemical equation is balanced. So anytime you want to balance a combustion reaction like this one, I highly recommend that you balance the carbon atoms first and then the hydrogen atoms second and save the oxygen atoms last. If you do it this way, your life will be a lot easier. Now let's try another example. So here we have butane, and we're going to react it with oxygen gas to produce CO2 and water. So this is another combustion reaction, but it's a little bit different than the last one, and you'll see. So go ahead and take a minute and try this example. So on the left side, we can clearly see that there are 4 carbon atoms, 10 hydrogen atoms, and 2 oxygen atoms. On the right side, we have 1 carbon atom, 2 hydrogen atoms, and then 2 plus 1. Don't forget about the invisible 1. So we have 3 oxygen atoms. Now, we're going to follow the same procedure. The first thing we're going to do is balance the number of carbon atoms. And so let's put a 4 in front of CO2. So on the right side, we're not going to have 1 anymore, but we're going to have 4 carbon atoms. Next, let's balance the number of hydrogen atoms. So 10 divided by 2 is 5. That tells us that we need to put a 5 in front of H2O. So now we have 10 hydrogen atoms on both sides. Now let's recalculate the number of oxygen atoms that we have. So 4 times 2 will give us 8, and then 5 times 1 is 5. So 8 plus 5 is 13. Now, 13 divided by 2 is simply 13 halves. So if we put 13 over 2 in front of O2, the equation is balanced. However, when you balance a typical chemical equation, you don't want fractional coefficients. Instead, you want whole numbers as your coefficients. And if you ever get to this point where you have 13 over 2, a fraction, or 6.5, a decimal, what you need to do is multiply by a certain number. In this case, whatever the denominator is, you want to multiply it to get rid of that fraction. So what we're going to do is multiply everything by 2. (13 over 2 times 2), the 2's will cancel, And so this is going to be 13 now. Here we had a 1, but we're going to multiply that by 2. So every coefficient that we see, we're going to multiply by 2. So 4 times 2 is 8, and 5 times 2 is 10. So now let's recalculate all the numbers that we have. So right now we have 2 times 4, or 8, carbon atoms. And we have 2 times 10, or 20, hydrogen atoms on the left side. And for oxygen, it's 13 times 2, which is 26. Now on the right side, we have 8 times 1, or 8 carbon atoms. And for hydrogen, it's 10 times 2, which is 20. And in the case of oxygen, it's 8 times 2, which is 16, plus 10 times 1, which is 10. 16 plus 10 is 26. So we can clearly see that the number of carbon atoms are the same. The number of hydrogen atoms are equal on both sides, as well as the number of oxygen atoms. And so that is how you can balance a combustion reaction. Now let's talk about how to balance a single replacement reaction. So here we have aluminum reacting with copper chloride, and it's going to produce aluminum chloride plus copper. Take a minute and try this problem. So we have aluminum, copper, and chlorine. So on the left side, we can see we have 1 aluminum atom, and we have 1 copper atom, but we have 2 chlorine atoms. On the right side, we have 1 aluminum atom, 1 copper atom, and 3 chlorine atoms. So this problem doesn't look too bad. The only thing that is different at the moment is the number of chlorine atoms. So how do we make them equal? Well, we need to find the LCM, the least common multiple of 2 and 3. 2 times 3 is 6. And so what we want to do is we want to get 6 chlorine atoms on both sides of the equation. To get 6 on the left, we need to put a 3 in front of CuCl2, because 3 times 2 will give us 6. Now, on the right side, we need to put a 2 in front of AlCl3, because 2 times 3 will also give us 6. Now, the number of chlorine atoms are the same. But by adding these numbers, the number of copper atoms and aluminum atoms changes. So on the left side, we no longer have 1 copper atom. We have 3 copper atoms. On the right side, we no longer have 2 aluminum atoms. We no longer have 1, but we have 2 aluminum atoms. Now, to balance the number of aluminum atoms, we need to put a 2 on the left side in front of Al. So this changes to 2. And so now these are the same. And in the case of copper, we need to put a 3 in front of Cu, so that there's 3 copper atoms. I said that wrong. So that there's 3 copper atoms on the right side. So now the number of aluminum atoms, copper atoms, and chlorine atoms are the same on both sides. And that's it. That's all you got to do in this example. Now, here is a harder example. So this is called a double replacement reaction. We're going to make sodium phosphate with calcium chloride, and we're going to get calcium phosphate, Ca3PO42, plus sodium chloride. Now, for a double replacement reaction like this, with those that include polyatomic ions, in this case phosphate, I don't recommend that you balance every element individually. Instead, you should balance individual ions. And it helps to know the polyatomic ions. So you need to balance the sodium ions separately, the calcium ions, the chloride ions, and the phosphate ions. You need to see PO4 as one unit for this particular reaction. If you try to separate the phosphorus and the oxygen atoms, it could be a challenge, particularly if there's another polyatomic ion. Let's say instead of sodium chloride, we had sodium sulfate. Trying to balance the elements separately in that case will be a disaster. So I highly recommend that you balance the phosphate unit PO4 rather than separating the elements. For this particular example, it's going to be very useful that you do that. So right now, on the left side, we have 3 sodium ions, 2 calcium ions, not 2, but 1, 2 chlorine particles, and 1 phosphate ion. On the right side, we have 1 sodium ion, 3 calcium ions, 1 chloride ion, and here we have 2 phosphate ions based on the subscript that's here. So which one should we balance first? Typically, I like to start with the polyatomic ions, the ones with the highest charge. Sodium has a +1 charge. It's found in group 1 of the periodic table. Calcium has a +2 charge, or sometimes written as a 2+ charge. It's found in group 2 of the periodic table. Chlorine has a -1 charge, and phosphate has a -3 charge. If you haven't learned this, don't worry about it. You can still balance it without this information. But if you know it, it's better to balance the charges, the ions with the highest charge, in this case, the phosphate ion. In my experience, it's been easier that way. So what I'm going to do is put a 2 in front of sodium phosphate so that the phosphate ions are balanced. So we have 2 on both sides. Now, I won't have to change that anymore. You'll see. Next, let's balance the sodium ions. On the left side, we have 2 times 3, which is 6. So this changes. Now, we have 1 on the right side, so we got to multiply that by 6. So let's put a 6 in front of NaCl. So now we have 6 sodium ions on both sides. Now, by putting the 6, we change the number of chloride ions on the right side. So this is now 6, which means we need to change this number. 2 times 3 is 6. So we need to put a 3 in front of calcium chloride to make this equal to 6. So now these two are the same, and these two are also the same. The last thing we need to do is balance the number of calcium atoms. And by putting the 3 here, it's already balanced. So this number changes to a 3. And thus, that is it. So as you can see, when balancing double replacement reactions, if you balance the polyatomic ion, or the ion with the highest charge, it could be any ion, it makes the process a lot easier. And also, if you have polyatomic ions, view them as one unit. Don't separate them into individual elements. So that's it for this video. I hope you like it. If you do, feel free to comment, like, or subscribe to this channel. Thanks again for watching.